Hello guys, and thank you for joining me for hopefully what is the last week of home learning. You'll be back as of next week with face-to-face teaching. I know that many of you will be really pleased about that. I know that I am. Now, if you haven't completed the retrieval quiz as of yet, please pause the lesson video and complete the questions by adding in your answer to the table. Okay, so let's look at our answers. Make sure you are self-marking, adding in the ones you weren't sure of, correcting the ones you didn't get quite right, and ticking the ones that you did. So the answers are as follows. The mass at the start of a reaction is always the same at the end, so it should be 28 grams for number 1. Be careful with number 7, guys. I noticed that a lot of you are using lowercase letters for chemical formulas. Now, if it's carbon dioxide, the carbon is a capital C. The O stands for oxygen, and we know oxygen is a capital O. Well done if you got your challenge correct, and if you worked out the mass of the oxygen being 0.2. Okay, so we've come to the end of our topic on chemical reactions now. So it's really important that we review what we've learnt. We look at the areas that we are secure with. We look at the areas that we're not so secure with, and we develop those areas. Now, all of the keywords for this topic are now being shared on the screen with you. None of these should be any new words. You should recognize them all. You might not be able to describe them all, but you can recognize them. Now, I'm not going to go through all of them. If there are any areas throughout this lesson that you think, oh, I don't quite understand that, or I forgot that, please use the resources on our Google Classroom from previous lessons to refresh your mind. So a quick overview of the topic. It was all about chemical reactions. We know chemical reactions happen when substances combine together, join together, or break down to make a new substance. We know that the chemicals at the start that react are called the reactants, and they react to make something completely new called the product. And we can use word equations to show this. Now, we looked at combustion reactions. We looked at the problems with those, with the products of combustion. We looked at thermodecomposition. We looked at oxidation. And then finally, we looked at conservation of mass. Good morning. So what have you learnt about chemical reactions? Have a little think, pause the lesson video, give yourself 2 minutes to think about what you have learnt throughout these last 5 or 6 lessons. Have you really? Well done. Yes, that's right. Oh, fantastic recall. That is brilliant. Okay, so thank you for your feedback, guys. In my head, I'm hearing all sorts of feedback of everything that you've learned. Very impressive. Right, we know that with chemical reactions, rather than writing out a whole paragraph about how we reacted magnesium with oxygen and it reacted to make magnesium oxide, we can actually use word equations to show chemical reactions. We know on the left-hand side of the arrow, we have the reactants, the chemicals that react, hence the name reactants. On the right-hand side of the arrow, we have the products, the substances that are produced. Again, hence the name products. Now, in a chemical reaction, guys, no atoms are created or destroyed. They're just rearranged into, again, a new product, a new substance. And that's how we know a chemical reaction has happened. Now, for this reaction on the screen, we could write it into a word equation. So we know that we've got our hydrogen and we've got oxygen. Those are our reactants. They go to make water. You could use symbols to also represent this in a symbol equation. Never mix your word and symbol equations. Please be mindful of that. And we know that at the start we have our reactants and at the end are our products. So we looked at examples of chemical reactions. Combustion was one of those examples. We looked at how fuel can burn and react with oxygen to give out energy. That is a type of combustion reaction. Now, there are two main types of combustion that can occur, depending on the amount of oxygen available. So we can have complete combustion, where the fuel completely burns because there is plenty of oxygen available. Now, the products produced in that reaction are always carbon dioxide and water. So we make carbon dioxide gas and water vapor. So the word equation for that would be fuel plus oxygen goes to make carbon dioxide and water. Now, your fuel, guys, could be any type of fuel. Oh, there goes the bell. Lesson time. So the fuel could be any substance that burns with oxygen. So, for example, it could be methane, CH4. It could be paraffin. It could be wood. There's lots of different types of fuels that we can burn for energy. Now, on the opposite side, we have incomplete combustion. So when there is a limited amount of oxygen available for the fuel to combust, it won't burn fully, it will burn incompletely, hence the name incomplete combustion. And rather than making carbon dioxide, it makes carbon monoxide. And we know that is actually a toxic gas, it's poisonous for us. It can also give out pure carbon in the form of soot particles and water as well. Another type of reaction we looked at was thermodecomposition, breaking down a compound using heat. Now, the substance that we break down is usually a metal carbonate. So when we break down a metal carbonate, when we heat it above a Bunsen burner, it breaks down into two products. So we've got one reactant here, we heat it, and it breaks down to make a metal oxide. And because it's a carbonate, it will always release carbon dioxide gas. So let's look at an example. If we had copper carbonate, copper being the metal, copper carbonate. When we heat it, it breaks down to make a metal oxide. Well, we know our metal is copper, so the metal oxide will be copper oxide. And because it's a carbonate, we always get, yes, well done, carbon dioxide gas. Now, we looked at oxidation reactions. We know oxidation reactions happen when oxygen is added to a substance, hence the name oxidation. Wow. Now, let's look at some examples. If we had magnesium and we were heating it in a flame, it actually reacts with the oxygen in the air around it to make magnesium oxide. The oxygen is joined with the magnesium, and that is why it is an oxidation reaction. Now, we can convert this into a symbol equation. Mg for magnesium, that's a capital M, lowercase g, plus O2 for oxygen gas. Oxygen on the periodic table is just O. However, in the form of a gas, there's two atoms joined together. We say it's diatomic, two atoms joined together in a molecule. And it makes magnesium oxide, MgO. MgO. Now, moving on. If we add carbon and it reacted with oxygen, it makes carbon dioxide. And guys, we know it's oxidation because the oxygen has been added to the carbon. And again, another example, making sulfur dioxide by reacting sulfur with oxygen. And because the oxygen has been added, it is an example of oxidation. Now that leads us on to the final lesson of the topic, which we covered last week, and that was all about how we keep the mass of a reaction doesn't change. So we call this the conservation of mass. The mass of the reactants should always be the same as the mass of your products. So that's a simple way of writing it. However, if you wanted it in a sentence, we know that during a reaction, no atoms are lost or destroyed. No atoms are made. So the mass of the product will always equal the mass of the reactants. Now, let's look at this in terms of a reaction. If I had 32 grams of sulfur reacting with 32 grams of oxygen, what would the mass of my sulfur dioxide be? Now, remember, guys, you're always entitled to a calculator in science. So feel free to pump in those numbers on your calculator. And the mass of the product should have been 64 grams. Now remember, we measure mass in grams or kilograms. If we have magnesium and it reacted with oxygen to make magnesium oxide, and it made 56 grams of magnesium oxide, I know I had 24 grams of magnesium. The mass of my oxygen would be pumping the numbers to your calculator if you need to, that's absolutely fine. I would always double check myself. Should give you 32 grams of oxygen. So your task today, and this should take you a little while. I do want you to put lots of effort into it. It needs to be informative. It needs to be well presented. So you need to create a summary sheet for the chemical reactions topic. Now, you can use any format you wish. You might choose to do a poster on paper or an electronic device. That's absolutely fine. You might want to do a mind map or a spider diagram. You might want to do a PowerPoint. Now, guys, what I have done is I've completed a mind map just to share with you, to show you what my expectations are and to also give you a guide. Something that I haven't included there are the problems with combustion. So, for example, carbon dioxide can cause global warming. Carbon monoxide is toxic and poisonous. And if you inhale carbon particles, you could develop breathing difficulties and potentially lung disease over a long time. So you can use that to support you and to guide you and to take ideas from. And that's absolutely fine. So pause the lesson video, complete your own summary sheet of the topic. If you're working on paper, make sure you do take a picture and upload your work. I do look forward to seeing how well you can summarize the topic. So pause the lesson video, complete that task. Again, this should take you a little while. Oh, you're back so soon? Brilliant. I hope you worked really hard on that. And again, I do look forward to seeing them and how well you can evaluate what you've learned. So make sure you're uploading it or you're submitting it. Back to our student worksheet for today. I would like you, for your consolidation task, to complete the end of topic RAG rating. So at the start, we do a pre-topic RAG rating. Most of you should have been red, or some of you might have been amber. We do an end of lesson RAG rating. Most of you, I noticed, were amber or green for the lessons covered. Now I would like you to do an end of topic RAG rating. Once you've completed that, guys, please submit your work in order for me to give you feedback. I do look forward to seeing you all next week. I have missed all of you. Some of you. No, I have missed all of you. And it will be nice to have you back in the classroom and have a bit of human interaction again. Thank you very much for your time, guys. Some of you have produced some outstanding work throughout lockdown. So I've been very pleased and very impressed. Thank you for your time.